So now let's take a brief look at NX API. Now we're not going to spend a lot of time on this because, well, first of all, to some degree we will, in the sense that NX API is still the feature that we invoke within the Nexus 9K or 3K series of switches to get access to the API interaction and programmability interaction with the Nexus switch. However, the way that we used to do it in 7.0, 7.1 has changed dramatically. So we'll take a look at the old way, and then we'll take a look at model-driven programmability in the new way. So within NX API, this used to give us CLI interaction with the device over HTTP or over HTTPS, just like REST would. However, we did not use REST. Okay, so specifically, we weren't using the well-architectured framework where every managed object, for instance, every interface or every type of thing, like an interface VLAN versus a hard interface or a loopback, or a BGP process, or a GRE tunnel, or a, whatever the thing is inside, NXOS, let's say EEM, or embedded packet embedded packet capture, whatever the thing is that we're trying to run config for. In a REST API, everything would have their own separate URI, separate URL, right? We talked about this before. With JSON RPC, which we briefly touched on before, we basically have one URI that we hit from an HTTP, HTTPS perspective, and we format everything in JSON. And actually, we even had the availability here for XML. But within that JSON, we said JSON RPC, which is the remote procedure call. So it was JSON-like. Remember we talked about Captain Piet in Star Wars versus Benjamin Linus in Lost. They look alike, but they're not the same. So JSON and JSON RPC are different, and this is different than REST. The reason I'm saying we're not going to spend a lot of time on this is because now we have REST capabilities in 7.2, the Camden release, and later. So again, we've already taken a brief look at JSON RPC. We do get into the NXOS switch, and we run config-t, and we run feature NX API. Now this does run on the Nginx web server, okay? So it is, running on a HTTP or HTTPS-based server, and we make our JSON RPC call. Now on those older devices, and you may still have to interact with these that have older code, so this is why we're talking about it. Also so you can understand kind of just the history and where we've come from. Like I said, just in case you run that or run into those switches. Now, once you've turned on that feature NX API, that's all the more you need to do. You don't need to do feature web server, feature HTTP, or say, HTTP server or HTTP secure server like you used to maybe have to do on, let's say, an iOS device. Feature NX API is enough. Once you do that, you can point your IP address to the device, preferably over HTTPS, and then it will ask you to log in. Once you give it a privilege 15 username and password, then you'll have access to the NX API sandbox, where you can put in normal commands in normal, config-t command line that you're used to, and you can say post once you choose your format. Do you want it JSON RPC, XML, or JSON? And you'll find a difference between CLI and CLI ASCII. So if you post it, it'll tell you what in this case, JSON RPC, what the JSON RPC call is. And then it will show you, you can even click copy to clipboard, and you can see the response based on what command type you told it. Now, if you told it CLI ASCII, it would show you everything in an ASCII interface. So for instance, show interface would show you a human readable tabular or table format of all of your interfaces and status and etc. description. Okay. And VLAN association, for instance. This is going to be very different from CLI, not CLI ASCII, where you're going to see everything returned in JSON RPC format. So we also have within the NX API developer sandbox, point it to the IP. Once I do a particular command and post it, it will give me the option of clicking the Python button, and it will automatically generate Python code that would be used to send this payload, which is essentially the JSON RPC body, when I'm actually importing the requests, which is a particular library that allows me to send HTTP and HTTPS requests, get, post, put, delete, things like that, from within Python. And it's going to allow me to go ahead and send that using JSON dumps versus JSON loads. Talk about all that in the Python beginning engineer class. Using the headers that we had essentially used to determine or state our content type, application, JSON RPC, our MIME type, okay, and authenticate. So it gives you everything, and actually let me just go back. Then you can just click copy, and you could run this from anywhere else, and it would be able to connect to, assuming that you put in your IP address. Remember, this is /INS, so this is just the JSON RPC API interface through HTTP or S. Okay, recall this is not REST API, so we'll talk about that in a moment. NX API does use requests module or Python kind of sub-Python program or sub-Python configuration. You can read about this, but basically you do need to import requests so that you can use the request library or module, and you also need to import JSON so that it recognizes the JSON structure of serialized data. So for instance, this is an example in Python, importing requests in JSON, modifying, of course, your IP address, but not modifying the /INS on the older NXOS 7.0 and 7.1. Obviously modifying your admin username and password, and then everything else, you could just put in whatever command you wanted, and you would pass this along, and then you could print that response. And this is, I'm not going to go too deep into this, but this is basically calling out various subcomponents of the JSON return data, which is effectively in a library, and we're calling various keys. So the result, the body, and the RRSysVer or system version as keys, and then it would essentially return their values. Okay, so we'll get a lot more into how to deal with Python dictionaries and other things like tuples and lists in that Python for network engineers, really the beginning class. Much, much deeper into them in the advanced class as well. So here's an example just of the response dump. And again, you can look at this. If you just go back to here, you can see what that response is just in the sandbox, which is just the web page by pointing it at the Nexus 9K switch. But this is just kind of from a little bit larger perspective. So we're seeing all that information, specifically the body, and then here was that actually from the result, and then nested within that the body, and then the RRSysVer. So that's where we're seeing in the result, nested in the body, nested in the RRSysVer. Okay, so result is a key that has a value, which is another essentially dictionary, and then we have another key, which is body. So that's that second one, which is another dictionary. And then we have RRSysVer, which is the final key, and it has its value. So you were just seeing the value. So we could use this for monitoring health checks, wiring checks, CRC checks, memory usage. We can really use it for almost anything we can imagine. Gave another example that I had done earlier. Okay. So now let's take a look at quite a large section called model-driven programmability. So model-driven programmability, or MDP, is such a large section that it really has its own sub-agenda. First of all, what is MDP? Why MDP? An overview, various models, configuration and operational properties. What's the difference between a standalone switch and ACI or Epoch mode? We've already talked about what is representational state transfer, so we won't talk about what is REST too much. REST post get. And then a little bit of sample output, and we'll talk briefly about retries. So MDP, model-driven programmability, this is a new methodology of provisioning network connectivity. So this is a true, fully featured, fully functional, object-oriented software framework aimed at development of management systems. So the software maintains a complete and explicit representation of both the administrative and operational state of the system. And these administrative and operational states are maintained in the data management engine, or DME, as models. Okay, so what we were talking about earlier with ACI and the managed object model, which we're going to have a complete course just dedicated to programming ACI. So I know we didn't go too very deep in that. We are going to go into some examples here, or probably already have if you were watching this in the order as the how-to or kind of the hands-on demos were done. Or if they weren't published at runtime whenever you saw this. But we are going to go much deeper into a full ACI programmability course, into an advanced one. But with MDP for Nexus 9K and 3K standalone, we have the ability to automate our full network configuration in a systematic, programmatic way that's less prone to human errors using scripts. So we have an easy-to-use programmatic way. We support a variety of management agents based on a standardized managed object model or data model. And we can extract a lot of different varieties of data, either config, operational, from this. And we also provide, very importantly, role-based access control, something that really wasn't there prior to 7.2 when we were using JSON RPC, or at least not nearly as in-depth or granular. Okay? And the reason is customers are telling us hugely, by far and away, they want the ability to programmatically configure and manage their switches just like they do their servers, their VMs, their storage, their compute, everything else can be. So here's an example of kind of this data management engine or DME construct. So we have our network element module that has access through the CLI to this, and then access through via REST or possibly other agents like Puppet and Chef. Okay? So then this speaks down to the various NXOS applications that are running as processes. So again, whether we're dealing with the switch from a CLI perspective, from a REST client, could be a REST client like Postman, it could be a REST client which is just another programming language like Java or Ruby or Python. It could be through JSON RPC clients. We do still support that for backwards compatibility, or even SNMP. This speaks to the northbound API. The API essentially creates the code artifacts that are generated from the models. Those interact with the models, and then that uses the southbound API to actually program the backend processes. So what is a model? Well, it's a complete and explicit representation of a particular type of a system state. For instance, the runtime state of a switch. A port is operationally up and it's participating in spanning tree. There's going to be a model for that, or a managed object for that. Configured attributes, for instance, like a layers of a port or a BGP configuration, and even runtime statistics like counters, whether it's interface counters or LACP counters or whatever. Some examples of configuration and operational properties. So configuration properties, we have user configurable via CLI or via REST, right? Representational state transfer. So for instance, we can look at the layer of an interface, an IP address, an LACP port priority, the administrative state of an interface, a BGP neighbor address. Examples of like operational properties. So these are for application owners to update the properties. These are read-only for users. So for instance, what is the state of a port? We can't change the operational state of a port from an operational perspective. We can change them from a configuration perspective. So we can configure the port to be down, but we can't query the operational state and then say, it should have been down. We configured it as down, but we're telling the operational model that it's up. Okay, so those are read-only. For instance, remote device ID, or looking at show spanning tree path cost or show spanning tree priority. Now, just as a quick reminder of the differences between ACI and the Epoch, which is the Application Policy Infrastructure Controller, and the Nexus 9K standalone. So on the Epoch, the data management engine runs on the controller, the Epoch controller, but it also runs on the switch. In the Nexus 9K standalone, there is no controller, so DME only runs on the switch. On the Epoch, DME deals with logical models, coming from the controller, and it converts them to concrete models. In the Nexus 9K, the DME exposes the logical models built on top of the existing concrete models, or exposes the concrete models themselves. Okay? Because remember, we're not talking to a controller in this abstracted stateless environment. We have an individual fixed switch, and we can talk to DMEs on each switch, but again, we have these concrete models that were, or logical models that were built on top of these fixed concrete models. Okay? In a APIC, I may be speaking to leaf switches that don't yet exist, okay? Or L4 through 7 devices like firewalls or lost the word, load balancers that are physical or virtual that either don't yet exist, but I want to maintain the stateless configuration of for when they do exist or when I instantiate or spawn them later on. So from the APIC, this says no support for CLI, although we clearly know that the ACI toolkit provides that, and in the most recent version, we do have that kind of built in. So we have a pseudo CLI, but it is really a Python interaction with the system via REST API. It's not a native dedicated CLI. It's something that's built in based on that ACI toolkit. Whereas in the Nexus 9K, we do have a true CLI. So in the standalone mode, we do have a true CLI over the data management engine with sync semantics. So basically, the synchronization is there between these. If we do a command in CLI, it's going to sync with the backend DME. In the APIC, we have data management engine RBAC, or role-based access control. And now in the 9K standalone, we have role-based access control through CLI and the DME RBAC work together essentially natively now. In the APIC, we have a cold standby high availability, with standby soups getting their data from the controller after a switchover. In the Nexus 9K, we have hot standby failover with runtime and startup DME synced between the active and standby supervisors. So taking a look at the configuration flow, first of all, we have the DME policy element and the objectified app, so whatever it is we're trying to affect. And we can affect this through the CLI path, which is synchronous. So we do something, we're going to get something back immediately through the virtual shell. We do a CLI request. It does a call to the whatever it is we're trying to make the change to or show runtime state for, and we're going to get the CLI response. If we have REST, it's an asynchronous path, right? So Nginx is sitting on top as a web server on the 9K switch. There's a REST-based request to the DME, and the REST response comes back, but the information is, So for instance, if we make a request to make a change, so like we say, send, essentially change an interface state to up, for instance, the REST request is going to be sent, the response would be gotten, and then that configuration would be pushed. And this is very similar to the way the ACI APIC provides REST as well. We get back that response, which doesn't necessarily tell us if it was successful or not. And this may seem bad, but this is part of the model of REST. What we get back is a response that, for instance, 200 OK, that we had no syntax errors, and now it's based on promise theory. So the declaration of what we want, the DME is essentially promising, okay, I'm going to promise that I'm going to make that configuration, but then we would have to do another REST request to find out if that was successful or if there was a fault raised. Okay, so there is a bit of difference there that we do need to keep in mind. It's the same way that we deal with the ACI APIC. So we've already talked about what REST is, so we're not going to go through this again. Again, here, now actually this we will take a look at. So this is an example of a REST post specifically to the Nexus 9K or 3K really, same model. So HTTP or S, hopefully, / the IP address of the box, and then / API. And just like we talked about with ACI, we have / MO if we're going to have the fully qualified or essentially distinguished name. So /sys. So in ACI, we had /uni / something. Here we have /sys as that top level, /int for interface, and then phys dash, and then we have left bracket eth1 / right bracket .json. So if we made that post with this body, that layer 1 physical interface is the key, the value is a dictionary or sub configuration, I guess dictionary if it was Python, not if it's JSON. So the actual value is the subarray with attributes as another key or attribute, and then the actual value of that being another subarray where we have ID as a key, and the value for ID is eth11, and the next key is layer, so we have a comma, layer, and then the value is layer 3. Okay, so we know that basically what does this do? This turns eth11 into no switch port or a routed interface. Okay, and if we did a REST GET for that, we would get all the information back. Now this is actually the Python, or sorry, not Python. Too many things I'm thinking of. This is the Postman client, which is, as I mentioned before, just a free Google Chrome extension. So if you have the Chrome browser, you can add on the extension or downloadable kind of app, Google app for Postman. And we can do an HTTP post or GET. And if we posted this body, first of all, we would have had to have already been authenticated and within the window that we hadn't been logged out or our token hadn't expired. And then assuming that everything works properly, we should get back pretty much the exact same thing we get back from the Epoch, which is a status of 200 OK and the actual body of open curly brace, IM data, and then left, right, square bracket with nothing in it, and then right, close, curly brace. Okay, so basically, this is the response we got back immediately. It has not yet applied that, and then it applies it. Remember, it's asynchronous. So sample of GET, again, Postman, we get the interface, and assuming that we make our authentication properly, and then we make our call syntactically properly for the API MO, we're going to get back the total count and the IM data, and we get back all the information. And if we would have sent this in .xml, we could have got it in XML. Instead, we're getting it in JSON. So again, REST does requests, and these are applied asynchronously as we just talked about. So the configuration could fail to be applied due to some sort of a transient condition. For instance, a temporary resource shortage, maybe the required dependent object for the current configuration isn't present. So for instance, we tell it E185 and there is no E185. For such cases, a retry would be needed. Now, E185 isn't going to need a retry, but let's say something else wasn't working. BGP hadn't previously been configured, but we tell it to make a change. So we may need to update or fix whatever the dependency is if it wasn't just a resource shortage, but then we would need to retry our API call. So for instance, when the config failure does occur, the backend application will actually automatically set a flag in the DME to indicate that the configuration failure has occurred, and it will then retry applying the configuration automatically after 30 seconds. So this is a nice feature. And we do have, finally, a feature, copy, run to start, and also reload upgrade. So in copy, run, start, and reload, both the DME data as well as the backend data are persisted in something called the PSS. So upon reload, the backend applications would restore the data from the L PSS, and the DME will restore from its database. Now, no notifications for any configuration would be sent by DME to the backend applications during this time. Okay? And for an upgrade, the DME does not have any knowledge about the objects that were created in a previous release. So after the upgrade, the DME would basically do a pseudo ASCII replay and populate its management information tree, or MIT. And the backend applications would then restore their database from this LPSS. And again, no notifications would be sent during that time. Now, there are a couple caveats to MDP today. So today, MDP and SNMP cannot coexist on the same switch. You can have one or the other. Another thing would be that, for instance, FEX interfaces are not configured via DME or the REST API. They're configured the legacy way through the traditional CLI that does not go through DME. Same thing goes for host interfaces that are port channel. Now, FEX interfaces from the FEX to the switch can't be configured. Host interfaces on the FEX can be configured through DME. However, host interface or HIF, host interface, port channels also must be configured the legacy way. So finally, getting to the end, we have troubleshooting. And for any issue, it is imperative to check both the DME and just to make sure that the backend and the DME are in sync. So to check the DME, you can either do a REST GET just to see if it's at the state that you had basically told it to be, or you can use Visori. Now, if you're familiar with ACI or you saw what we had done earlier, Visori, which is Italian for to see or to view, at least as best I know, I don't speak Italian, so apologize for Italians out there watching this. Okay, you know more than me. Anyway, Visori essentially allows us in ACI to be able to, it's also referred to as the object store browser, and we can look at the entire management information tree, the entire managed object model, and we can look at any one managed object or any class of objects in Visori in ACI. And the same thing holds true now in the Nexus 9K switch. So we still do it the same way, point at HTTP or S to the IP of the switch instead of the APIC, like we would in ACI, and point it to visori.html. Now again, this can be used and pointed to as soon as we enable Feature NX API. So we're still running Feature NX API to get all this functionality, the REST functionality. It's just that now we're using REST calling the DME instead of JSON RPC. So here's an example before we actually dive into our hands-on examples, but just from a kind of a slide perspective or a quick view perspective of Visori for the Nexus 9K standalone. And again, we are logging in and hopefully using HTTPS, and we can query either a class or a specific distinguished name, and it looks identical because it's all the same code, right? It's still the object store browser, but it's now just for a Nexus 9K standalone switch. And so if I had 20 leaf switches and 2 spines, in each in standalone mode running VXLAN with EVPN or anything, they would each have their own Visori. Okay, versus ACI where I have one APIC controller or a cluster of controllers that have Visori that represent all the switches. In standalone, I have to go to each one of them individually. So then I can log in and I can look at either a DN or an entire class. So for instance, I can see the DN is sys interface, and then I could also query the class. I could click on this, or I could query the interface entity, and that's going to return all the classes that have all these different DNs. Okay, so now here I'm in layer 1 physical interface, or L1 phys if, and that's the class. And then I see all of these properties or attributes, one of those being DN, and I can see the actual distinguished name. And I, again, have the same things I have in ACI, which is I can drill back up to the parent. That's what that's left less than is, or drill down into all child elements, which is the right greater than. I can look at all the statistics. That's what that little graph is. The red, I can look at all the faults for this particular port. And H, I can even look at a health score now.